Alright, I'm going to test a new format here. This is going to be programming videos and more specifically ROM hacking videos. So before I get into any actual disassembly, I should explain what we're doing here. We are disassembling a Game Boy game called Keitai Denjuu Telefang, also known as Telefang or Pokemon Diamond and Jade if you listen to some particularly egregious Chinese bootleggers. And for the past 5 or 6 years, there's been a fan translation project that I have on and off contributed some work to. And the issue, which caused me to sort of go on hiatus for a couple of years until I remembered that this project still existed, was the fact that we did not have a proper assembler or build process. So we have about as much source code for our patches as we have for the original game, which is to say, none. So what I have been doing over the past week or two is disassembling A, the base game, as well as B, our own patches to figure out how those work so I can maybe reorganize them, and also so we can apply it to the other version of the game, because like every monster catching game on the Game Boy, it had 2 versions, power and speed. We patched power only and didn't even bother with speed. So not only is this disassembly important for being able to work in a relatively sane environment, it is also essential for getting a translation of the other version. So, the routine that we are currently working on is the main script routine, which lives in Bank B at 4130C is the control code interpreter, and that has been patched to all get out to manage a variable with font system that didn't exist in the original game. Now, for an RPG like this, or really any game on a system this old, there are 3 different ways to actually render text onto the screen. The first way is to use character cell graphics, and if you are familiar with a Commodore 64, it's exactly what you expect. Each 8x8 tile is allocated to a single letter, and then each letter is mapped to a particular location on the screen. It uses very little VRAM, but you don't get variable with text. It does not look very good. This is most common in lots of NES games, because most NES games did not have VRAM. It had VROM, as in a ROM chip with all of the character graphics on it, and then a little bit of RAM to do name table mapping, which is how the actual tiles were rearranged to get onto your screen. The second option is sprite text, which, if for anyone who followed the Mother 3 fan translation, was a real pain, because when they moved to a variable with font, they suddenly increased the sprite load to the point where the game was constantly crashing, because Japanese text is almost all large squares, while English text is much thinner and presents different challenges. However, Telefang does not do either of these. It is actually a proper rendered text system where the game will actually have a set of tiles stored away for rendering text to. It will not actually store a tile for each letter of or syllable of the font. It will actually draw from a font onto proper tiles, which is much more in line with a more modern text rendering system. Sorry about that. So, we decided, in fact this was before I even found out about the project about 4 years ago, we decided to take advantage of this and write a proper variable with font system. And that necessitated a lot of additional code. So in our current build system, it will actually tell me when new code does not match up with the base ROM. And in this case, this is our patched base ROM using our old IPS patches, which you can actually use and play right now. It's not fully translated yet, though. We probably should, I would say we should eventually be doing like some sort of draft. So I'm going to go ahead and just take this comparison, verbose comparison 183850, and that's 2CE, 2A. I have 4 different IDA disassemblies. So on the left we have power version, right on the next to the right we have speed version. These are both the Japanese ROMs. We have a disassembly that I've had for a while of an older version of the Fantranslation project, power version, and we have a disassembly of the latest published version, which is like a year old by now because this project has been inactive for about as long due to various management issues. So I will be switching between the two. So what we do with any of this, anytime we have a report of a byte difference, we have to go and figure out why that is wrong. We are going to jump to 2CE2A. You can't see it because it went on my right monitor. And that is a jump into a new text rendering. When I started this, I called it advice from aspect-oriented programming, and in fact I've kept that naming scheme here as well. So this particular set of advice just stores the current letter, pushes some stuff, and jumps back to where it came from. So we are going to switch to the draw text routine. Main script draw letter is what is here, and if I look back into the original base ROM, 2CE29 has just the push HL, and as you can see I've already disassembled that on the base ROM, and now we need to do the English patch as well. So I just need to declare section main script text drawing advice, and this is going to live at 4C00. See, that's the other problem of not having an assembler, is we put all of our code wherever the hell we felt like it, and there's NOP slides everywhere and all sorts of other stuff that only makes sense if you're directly hexing code into a ROM. Bank B is where all of the text rendering code lives in the game, and we're going to call this main script advice store current letter. Do not export that. Load WVWF. Sorry, W main script VWF current letter. If you're watching at a particularly high resolution, you might have noticed that the actual names of all the variables do not match from disassembly to disassembly, because this file is like 4 years old, this one's 3 years old, and this one is 2 days old. These disassemblies are never going to be made public, so I don't need to worry about that. And really, I just need to worry about using the names that I actually chose. Or otherwise, I will get yelled at by the assembler. So push HL, load B0, and then jump back to main script underscore draw letter dot. Oh, by the way, we're also using a patch version of our GBDS. It allows inter-function local jumps, because the original game does that a lot, and our patch is even more. So main script draw letter come from store current letter, and we are going to place that label right over here, and we're going to put a jump to main script advice store current letter. I really wish that this text editor had a mode for Z80 assembly, but it does not. And now when we build that, we're going to do min GW32 make since I'm on Windows. And it's going to go through, rebuild that module, and then yell at me because there's 20 other differences. And if we go into our comparison, we will find 183297, so that means the number went up, and this routine has been properly addressed. 183297 is 2CC01. Which is, what the heck is this function even? Okay, so calculate lines from tile 1. What the? I don't even remember disassembling this routine. Which means we shouldn't be getting any differences in our base patch to our assembled one. If I go into the symbol map, I can find a this doesn't tell you what oh, there is the bank. So bank 11. Why is this not hexadecimal? Bank B. Okay. This would 2CC01 would be 4C01, and I do not have any symbols there that it should be overriding. So what we have to do then is figure out why is this not hold on, is this overlaying over the correct ROM? Because this is supposed to be generated purely for accuracy of our own disassembly, not for actually building the new version of the patch. So base ROM power patch, ROM's power patch. ROM's power patch is Telefang patch. Alright. So, boy. 183297. Huh. There is literally no reason why this should be even showing up in our difference list. Unless some other injection has just overwritten this entirely. But I don't think we have anything else other than the assembler. And now I've just realized the problem is I put the device at 4C100 instead of 7C100. Rebuild. Going to compare. And we find that, yes, we are, come on, 183873, which is 2CE41. 2CE41, which is further on in our disassembly. And does not actually appear to be different. We didn't actually relocate that, so 873, which is the address of the load A instruction. So let's go to main script text style. Again, same address, CDB1. And our symbol map shows, let's see, CDE. I probably should just type main script text style. CDB1. Okay, so the next question is there some... No, it can't be overridden because this address is already taken and the assembler will not assemble on top of another bank. It will fail in the assembly or linking phase. So we have a jump, add, no carry, increment, multiply, load, add, pop, read, compare. Boy. First video, I'm already embarrassing myself. 183873. Then it just ends. What the? Everything beyond that is all nulls. Which is not what is in my own disassembly. So, let's go to 2CE41 in the latest version of the patch, which I have not even disassembled this function, but let's go to 2CE29, which gives the jump to location which I have to fix, and that is going to be 2FC00 because IDA does not know how to disassemble a banked ROM. And what the heck? Someone moved all of this code and just wrote nulls all over it. Damn, that is some serious relocation. Like, to do that in a hex editor. Okay, so this is all the same up until here, where it jumps into an advice block. No, not even jump. It calls it and then returns. So this is 2F9C1. Now you get to see me attempt to disassemble stuff that is in the wrong, that is in a high ROM bank that IDA does not know how to auto-analyze. So pull up my symbol map. And we are going to search for C7C3. What the heck? Are these new byte value? Yeah, that's the compositing area. This should be in... Oh, okay, so... new thing is, if a symbol is not imported or exported, it does not wind... Actually, it is exported. If it's not imported, it is not in the symbol map. / I am looking at the wrong symbol map because I am an idiot. So there's our compositing area. Go back here. We can start disassembling this routine now. We're going to name this according to what is actually in our disassembly. We can't use actual macro variables, but we can get pretty darn close. We are going to look for C7C1, which is the current letter. I really wish IDA would put the window on the proper monitor, but who knows? This software is so freaking old and is one of those, it's professional grade, so it's expensive and barely functional, but you buy it because you are a malware analysis company or something else that is doing malware analysis. Okay, let's go back here, and first off, after the pop HL, everything is just gone and replaced with however many bytes of spaces. So this is 2CEA0 minus 2CE44. 5C. So I'm gonna delete this, stick it into, I'm going to cut this, then stick it into another file in case I need it later. Other than that, it's going to be a call into main script advice draw letter and then return. To be honest, I probably should be replacing all of these jumps with calls, but the point of this is not to improve the patch. The point of it is to get it to the point where I can build it on both versions and get it to work, and then maybe I can worry about refactoring. Maybe save some bytes down the line. So this new bit of code is at 2F479C1. That actually should go before this. Not like it matters. Section main script text drawing advice 2 ROMX 79C1 on bank B, and this is going to be main script advice draw letter. And we are going to look at the old code and find out that it is completely different. So I don't even know what it is doing, but it apparently is generating its own compositing area. Someone rewrote this entire routine since I left this project and then came back. So it sets main script BWF composite area A and D0 +1. Probably should replace that with a symbolic reference in CFD0. I think that will be 16 bytes. I'll worry about it later. Push HL, push BC. Actually declare 5C bytes of space, which will hopefully get replaced with NOPS. So push HL, push BC, load a main script BWF current letter, load H7B, load LA, XOR A, load B, HL, load A, W main script VWF letter shift, add A, comma B, bit 3A, JR, NZ. Okay, fix up some more things here. Can we get this to be 2F93E2 and 2F9E4, feed this to auto analysis. So what is this doing exactly? It is testing bit A of the letter shift to see if we are at the edge of the current tile, I guess. So I'm going to put, if it's non-zero, then at edge of tile. Sorry, off edge of tile. Otherwise, clear A / I should do this. Wait, no, this is backwards? Oh wait, no, never mind. I realized this is, the composite area is actually 2 tiles. So this should really say on second tile, XOR A JR dot done calculating tile, and then on second tile load A1, and then done calculating tile. These are like the worst variable names, I don't care. Pop BC, pop HL, push BC, push DE, push HL, push as fuck. Disable interrupts. Load the composite area. HA. +1. Increment HL. I'm not sure why they didn't just use auto increment if these are all clobbering A anyway. Whatever. Decrement HL. Load A, DE. DA, load E0, load A, W main script, VWF, old tile mode. So I wrote documentation on what the actual old tile mode does. I don't know if it's in here or if I'm going to have to pull up what I put on the Telefang wiki many moons ago. Let's see. Look for a RAM map, which is terribly inconsistent and out of date. And it's going to take forever. What the? Come on. I hate it when HTTP requests hang, and then I click it and it works immediately. Like, in what situation does it make sense for a request to be waiting longer to get delayed more than one that just came in? I don't know. I think it's an Apache misconfiguration on whatever host this is on. Old tile mode. Internal VWF bookkeeping used to manage the contents of the compositing area. When 0, the current drawing progress has not yet crossed a tile boundary and can be drawn through freely. Has crossed the tile boundary and the compositing area is globally moved left by 1 during drawing, so that drawing can continue. State 2 is never set by the VWF, but indicates that the entire compositing area is garbage. Okay. So I actually documented one thing correctly on this, which is good because I have to actually... IDA does not like... So that's 2 FA08, not FA07 plus 1. We're not jumping into the middle of other instructions to obfuscate ourselves. Sorry, IDA. That's 2 FAOA. That's 2 FAOB. Start our auto analysis again. Alright. Load the old tile mode. Compare to jump register. Relative jump to, we're going to call this erase mode, or uninitialized mode, or new line mode? Yeah, let's call it new line mode. If it's a 1, it is going into second tile mode, otherwise it is in first tile mode. So, in new line mode, we clear out C entirely, and in second tile mode, we load B from C, and then this is first tile mode, where we're actually going to load W main script, BWF, letter shift, or A. Okay, what is this? Fix up some more of these accesses. call this stop shifting. Otherwise, we have a shift loop. So SRLD, RRE, decrement A, continue. So basically, for a higher level explanation of this, in order to actually generate our variable width tiles, we have to shift them because the actual hardware works in what is essentially a very cobbled together and odd form of bit planes where every tile is separated into a byte consisting entirely of the high bits and then of the low bits. It's not entirely bit planes, it's not entirely chunky graphics, if anyone remembers those. For the record, modern graphics are closer to chunky. Well, for 2D, like graphics, 2D graphics has been boring for 15 years. Everything's 3D now, even 2D. So we have to actually physically shift bits over because the bits, these are 1 bit per pixel graphics, so the bit is directly translated to black or white background or foreground colors. And then there's a separate routine later that actually colors them. So, to get back to where we are, we're going to load AD, move 4B, so that just actually adds the bits that we've shifted back onto our tile. BACE, and then write this particular line back into the compositing area. Load HLB, inc HL, load HLC, inc HL. So this compositing area is stored differently from Game Boy Color graphics. Game Boy Color graphics have the high bits all in 1 byte, and then the low bits. This one has the first tile bits and then the second tile's bits. And then it has that 8 times to actually form 2 tiles that are stored in a most peculiar way. But then again, this is 8-bit microcomputing, so that's par for the course. And we are going to store our new main script VWF composite area. Back into work RAM so we can do other stuff with it. Read back our registers. Do some more registers shuffling. Oh boy. I'll disassemble that later. Okay, FA3F, which is 2FA3F. And it's going to call it again. Okay. Oh, this is really important. No, wait, fix that. This is going to be 2F again. And this is a bunch more code in another advice block that is... Okay, this is where the actual... I think this is where the coloring went. CDB1. I'll fix that later. Otherwise, pop these 4 things. I don't know what to call this label. Skip second whatever call. Load HL10, add HLDE, load AC, call this mystery function again, enable interrupts, pop AF, pop HL, pop DE, pop BC, inc DE, dec B. And that goes all the way back up here, so I'm going to call this tile shift loop. So that is just checking to see if we have any more lines left to update. Still would like to know what this does. BWF disable or a JRZ. So BWF disable is something I added to make the BWF go away on naming screens because it was breaking things. .2FA5D is this thing, and then this is .2FA5EF. So this is what? It loads a and then okay, what is BC? BC is 7B. Oh, this is actually loading the width. Okay, so use width table, load A8, then jump relative to add width. So there's another table in ROM that actually stores all of the letter widths, and that is what gets used or not used as the powers will want. Inc A. I'm running out of energy, so I better get this done before I just conk out on this keyboard and then ruin my disassembly. Alright. Add with, load BA, load A, W main script, VWF, letter shift, add AB, bit 3A. Obviously we've done this before, all the way back up here. So we're going to call this on second tile again. And I should fix this up. Save my disassembly. Hold on. Okay. So that is actually inversed and I'm an idiot. Okay, no second tile shift. Back. Okay, subtract 8, push AF, load A1, load W main script, BWF old tile, load A, W main script, BWF main script hack. Wow, I've been on for 39 minutes. I'm surprised I haven't filled the disk by now. What is this location? So the main script hack is something I don't entirely understand. Let's see. I don't even remember why I called it main script hack. I'm just going to call it no new line hack for this jump. Otherwise, load A0, load W main script, VWF main script hack. Okay, so that's just disabling it. Which means we're going to have pop AF and then this is going to load W main script VWF letter shift A ret. Okay. We have a disassembly of this routine, so I can go ahead and build it. Skip second whatever call. That's all the way back up here at the load 10. Alright. To do disassemble mystery function. Build it up. And it failed to link. Line 93. What the? Okay, that is not how this works. That is not how any of this works. I don't even know why I thought that would work. Load a VW or a JRZ. Can't do or a and then a label. How does that even? How did it get to the linker phase? VWF leftership. That is how you can tell that it is way too late for me to be doing this crap. But we have shorter comparisons. I get very wary if the comparison looks like something's been shifted. Usually that means something bad happened and I skipped a couple instructions. 185258. So this is 2D3AA. Which I have never actually even encountered this routine. So I'm going to call this disassembly a success for now. I'm going to commit it. Let's see. Add VWF drawing routine. Most of it. And then I'm going to call it for this video before my SSD fills up. So yeah, hopefully I can make more of these in the future. I enjoyed actually explaining this crap. Hopefully someone enjoys watching it. If not, meh, whatever.